tell us that it was a different group of people involved in it. Some people were from Africa, some were from Europe, all parts of the world. Why did they try to do that? Because they want to solve the problems. Because, you know, mathematics is all about problem solving. Mathematics is all about problem solving. What problem were they trying to solve? One, they wanted to know, they wanted to navigate the space, especially the moon, the sun, actually the territorial part of the earth, like the space. So they wanted to discover more. So there was no, by that time, there was no serious machines. Like these days, we have technologies everywhere. People can do what, people can fly to the moon, people can go to the what, any planet, people feel like people can study things from the earth, people can go to the Mars. But those days, those things were not there. The level of technology those days, those things were not there. Then there's this French man, the man called D'Alembert. What's the name of the man? It's written like this. This is his name. How do you pronounce this? He's a French mathematician. He's a French. Who Tati? He's a French mathematician who came out with the idea. And for him, he was using a stick. He was using a stick. Why? Following the direction of the sun. So he got two sticks, then he put them in L form like this. He was putting them like that. So as the sun moved, they form shadows. They form shadows. Then they were using that one to tell time. So if the sun moves, like even in some villages where there are no watches and clocks, people still use that. People still use the same idea of using the shadows. Where did they come from? It came from this man. So the man got a stick and he put them in L shape. And the reason why he was putting in L shape, so that he minimized the number of times you have to come and keep moving the sticks. So he put this one maybe in the morning, then this one in the afternoon. So for him, he decided to put them in L shape. Are you together, members? Are we together?
Yes.
Yeah, so as the sun keep on moving or the sun keep on rotating, they form what? Shadows. So he's put one in the morning, then this one will give, maybe it will help to give the time in the afternoon. That's how those people those days used to what? To put or to measure time or to tell time. Why? Because by that time, all the land, the landmarks had disappeared. The landmarks have disappeared. You can't tell the boundary of anything. So for him, he decided to use that because people used to use shadows. They use the trees, but those things were disappearing because of different climatic problems. Like now, and the same problem I think we may experience in some years to come because of climate change. Some of the vegetation we see on the planet will disappear. And if they disappear, we have to start thinking of how to survive again. And these people, they had to use their brain and they brought something that we are using up to date. What about us? If these things disappear, what will we do? That's the basic of mathematics. We must use mathematics to solve. We must use mathematics to solve our daily problems. So this man came out with the idea of trigonometry. And then then another man came from, a man called in the name of Eliot. Okay. This one is a Greek. Okay. So he also came and bind in. Then for him, he started using modern technologies. He started improving what they've already developed. That's why now these days when we look at mathematical sets, we have special shapes. We call them special. Why? Because they're the one who came out with it. We have all these shapes here. All these things we are seeing here. They were developed by this man called Eliot. Okay? Okay? Members, are we together? Are we together? Yes. And this one, they are special. They are what? They have the meaning. Don't think that they were just designed for the sake of, because they can. There's a reason for it why this one is this shape Why this one is this shape? Why we have a protractor like this? There's a reason for them. The reason why this one is circle, because it's circular in nature, is because they assume the earth is circular in shape. That's what they were thinking by then. And people, when we grew up, people started developing. Those of Newton came in, those of Albert Einstein came in, those of Pythagoras came in, those of John Napier came in. They could not improve. They said, this is a gospel truth. Let's go with it. There's nothing to debate about this. Let's continue with it. Okay? Are we together, members? Are we together?
Yes.
Yes.
Teacher.
That's why today, even in my lifetime, I'm still using the same thing people were using over how many years, millions of years back. And how did they develop this? Because of climate change. Because of climate what? Change. The climate change for them, they were experiencing the landscape and the sea. They all disappeared. You cannot trace anything from anywhere. So they were trying to navigate. They want to find a way of how to navigate the planet, the space. I told you they started using with a what? With a what? With a stick, not so. Members, are you with me?
No, teacher.
Yes?
Teacher.
Yes, please.
By then there wasn't. By then there were no seas. By then.
They were there,
By
but
then.
it was there, but time came, things started drying up because of climate changes. Yes, the oceans, the water bodies, they all dried up, even all the vegetations disappeared. So they could not give direction clearly. So they started using rudimentary, let me use this word from geography, rudimentary tools. So they started finding a way of surviving. Like now this man, this French man started using a stick, following the direction from the sun, following the direction from the what? The sun. So he could put stick like this. I know, I'm very sure. I know.
Yes, teacher.
I'm very sure even still in Gulu, up to now, people still use sun. They still use the direction of the sun to tell time. Am I lying? Up to now.
I'm not sure.
There are some people who still use what? The shadows, the direction of the what? Hey, the shadow is now, the sun is this side, which means it's already one. It's time, it's lunch time. That's how people were surviving those days. Okay? Yes. And history has demonstrated that over the years, what bring the great men and women is because of problems. That's why I think for us, sometimes we don't have problems like the Europe and Americans have, or they have experienced. Yet, because for them, they have gone through a lot, up and down, so many. That's why for them, that they have great thinkers. They have great what? Thinkers. And history has demonstrated most of them, when they were doing experiments, they were all in Africa. Pythagoras was in Africa. John Napier was in Africa. All of them were in Africa because African became a what? A laboratory for proving everything, because everything could be found in Africa. That's why people even these days find people coming for you see all these studies coming to Africa. Why? Because we are a very rich continent. On that we don't know. We don't think. We think God has given us everything and we should just take them the way they are. Are we together, members? Are we together?
Yes, teacher.
So, and my contribution is to make you think. Don't ask me, teacher, what have you done now? For me, what I'm doing, I'm talking to you. Okay?
Yes.
A time will come when I'm not there. I don't know how people will behave in 2050. But if you see the way the climate changes people are experiencing, like Anua is saying, Gulu is very old. What is causing all this? These are climate changes. Time will come, all these vegetations, all these what? Will disappear once again, like it disappeared 200 years back. I mean, 200 million years back. Are you together, members?
Yes, teacher.
Because this French man here, he discovered this thing. He started bringing the idea of trigonometry in 1751. In what? in 1751. And for him, he started from where other people have already started. He was asking himself, how can I improve life? How can I improve life? How can I improve? How can we tell our stories? That's why these days, now we have different what? We have different means that we can use to solve problems. Are we together, members? Are we together?
Yes.
And trigonometry was developed by mankind. Was developed by man what? By mankind, because it allowed reading of even people, because people want to see even what is taking place, because in those days people believe the heaven is in space. That's what people used to believe. Whenever you see up, that's why those days when people are praying, they look up, because they believe that's where God is. Are we together, members? Are we together?
Yes.
Yes. So the Denmark came out with this idea so that it can help them to navigate the essential part of the earth, like the space, like the water, like the space. Then there's a man who now we call him this one here. This one is what? What is this?
Virus.
This man also came out. He said, no, this thing must only be in 3D. We must see only 3 sides. We must see only what? 3 what? 3 sides. Why? Because when this man was putting a stick, the shadow of these 2 objects will form 3 sides. The shadow of these 2 sticks will form how many sides? Members, will form how many sides? 3 sides. Now for him, he said, no, this thing must be in 3 sides. That's why today we have, and this one over the times now, people have this, people now, the modern time, we call him now Pythagoras. We call him what? We call him what? Pythagoras? We call him Pythagoras. That's the modern name, but those days we used to call him what? Pythagoras. I think that, members. Yes. Yes?
I have a question.
Yes, please.
These notes on the screen, should we copy them?
We are going to copy, but I'm still giving history of these things.
Okay.
We are going to write them. We are going to write them. But these books are already on the website. I believe many of you have their copy. So trigonometry did not stay very long in that process. Then engineers, great mathematicians came out to study. They put it now in a branch of mathematics we call trigonometry. We call what? Geometry. What? Geometry. Because geometry was dealing with shapes. Geometry was dealing with what? With shapes. Like the triangle, like the what. So because of these people's idea, they discovered any figure with 3 sides. Any figure with what? 3 sides should be called triangle. Should be called what?
Triangle.
That's why if you look at triangle, triangle is not the English word. Okay? It's a Greek word, which means 3 in English. In English means what? 3. Are we together, members? Are we together? Members, are we together?
Yes.
Yes. So that's a brief history. That's a brief history I feel like I should give you. People like Archimedes' principle, now what we call Archimedes' principle it was discovered by a man called, also he contributed on this aspect. It also contributed in discovery of trigonometry. So the history is very long. If I'm to talk about it, I will talk until the cows come back home. Okay? Are we together, members? Are we together, members?
No. Yes.
Have you got the history? Have you got the history? Okay. Stop adding trigonometry. Let's now look at trigonometry now in modern time. In modern time. Trigonometry. Trigonometry. Tri what? Trigonometry. 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 So like I've said, I said trigonometry is not an English word, it's a Greek word. It's a Greek word, which means trig, which means three figures, trig, which means three sides. Then gonometry, gonometry, which means to measure angles, means measurement of what? Angles. Measurement of what? Angles. So that's a brief history about that. That's a brief history about that. So let's go to definition. What is trigonometry? What is trigonometry? Trigonometry, definition. Trigonometry is a branch of mathematics. Is a branch of mathematics. Is the branch of mathematics. Is the branch of mathematics. Or geometry. Or geometry. Or geometry. Concerned with the relationship between the length of sides of triangles and their angles. And their what? Their angles. And their angles. And their angles. Full stop. And their angles. Full stop. Full stop. Under this topic, let's say there are three special trigonometric ratio. There are three trigonometric ratio. There are three important trigonometric ratios, and these includes we have the sine, which is in short form we call it sin. Okay. Then we have what we call the cosine. The cosine in bracket, in short form we call it cos. Then we have tangent. We have what we call tangent. In short form we call it tan. What? Tan. They are special indeed. They are special. This is what we use to give the relationship between angles and sides of a triangle, of any triangle. Triangle. Are you together, members? Are we together?
Yes.
Yes. So sine, in short form, we write it as what?
Sin.
Cosine, cos. Tangent, tan. Okay?
Tan.
Yes. Yes. So that's how we used to, and they are ratios. They are what? They are ratios. So this one measure angles. This one help us to give angles. So let's see how we can look at the details of it. Let's say consider a right angle triangle. Consider a right angle triangle. ABC. We know what a right angle triangle is, not so? A right angle triangle is an angle where one of the angle is what? 90 degrees. ABC. And full stop. And comma, sorry, and the angle, the other two angles are acute angles. Are acute. Are what? Are acute. And one angle is 90 degrees. Is 90 what? Is 90 degrees. One of the angle is 90 degrees, then the other are acute. The rest are acute. We know what acute angles are. I remember discussing that when we are looking at angles. So let's draw this. Let's draw this. If this is our right angle triangle, members, if this is our right angle triangle, like that, so like that. So this is A, B, C. Let's say this angle is theta. That angle is theta. We know the symbol we use for angles. The common symbol we use for angles are, members, who can remember the common symbols? The common symbols we use for angles are? We have theta. We have theta. The symbol is this. We have beta. The symbol is this. We have alpha. The symbol is that. Those are the common symbols we use. Okay? Are we together? Members, are we together?
Yes.
If
teacher.
if you are to use letters, if you want to use letters of alphabet, then you must use small letters. Then you use small what? You use small letters. Are we together?
Yes.
Yes. So this is our right angle triangle. Now we want to define them. How did Denmark define these figures? He defined them by giving them specific names. By giving them specific what? Names. So he said the longest side AC. This one is the longest side of a right angle triangle. So he said, let's write down there. The longest side AC of the triangle is called the hypotenuse. Is called the what? The hypotenuse. So AC is called what? Hypotenuse. Is called what? Hypotenuse. Hypotenuse is called hypotenuse. So in short form, we just write it as like this. Okay? Are together, members? In short form, we just write like that. Then the side which is BC. BC, because when you are defining them, we look at the angle. You define them with the angle. This is the angle. So the side which is opposite to this angle is called the opposite. Is called the what? Opposite. So BC is called what? BC is called what? Opposite. Why are we saying it's opposite? Because it's opposite to the angle. It's opposite to the what? To the angle. So in short form, opposite, we just write it OPP. In short form, that's how we write it in short form. Then AB, the side AB, which is close to this angle, the side which is close to this angle, AB. The side which is close to the angle is AB, which we call it the adjacent. We call it the what? We call it the what? Adjacent. Adjacent means something close. Adjacent means something what? Close. Are we together? Hypotenuse, this is the longest. This is the longest side of a triangle. Then this is it, the opposite face to the angle. Opposite what? Face to the what? To the angle. To the angle. Then this is the side which is close. Close to the what? Close to the angle. Are we together, members? Are we together?
Yes.
So it means if I'm to use this angle here, if I'm to use this angle, let me say this angle is beta. Then what is our opposite? Which side is our opposite, members? Angle beta. Which side is our opposite?
AB.
AB. Then which side is our adjacent? Which side is our adjacent?
BC.
BC. Then what's our hypotenuse?
Yes.
A what? AC. Excellent. 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 Good. I'm just explaining because I believe people have these notes already. That's what I'm believing. That's why I'm taking. I'm just explaining the notes. Okay? Are you together, members?
Yes.
Now let's define them. Let's define these trigonometric ratios. Let's define them using right angle triangles. Definitions. Let's define them. Definition of trigonometric ratios. Definition of trigonometric what? Ratios. Members, what are these trigonometric ratios? What are these trigonometric ratios? We have sine, cosine, and then what? Tangent. Okay?
Tangent.
Yes. In short form, we call it?
Okay.
In short form, we call it what? Tan. Okay? Yes. So we said they are ratios. We said they are what? They are ratios. They are ratios. So for any angle theta, for any angle what? Theta, for any angle theta, comma, trigonometric ratios for any angle theta, trigonometric ratios are defined as let's start with the first one. So sine of any angle theta, what? Theta is given by opposite over hypotenuse. That's the definition. That is the what? The definition. Are you together, members? Are we together?
Yes.
Sine of any angle theta is opposite over what? Over hypotenuse. Why are we saying over? Because they are what? Members, they are what? They are what? Because they are ratios. Because they are what? They are ratios. So which means it implies now sine theta is equals to, what is our opposite from here, members? What is our opposite from here? Our opposite is B. B what? BC. BC over what? BC over, what is our hypotenuse? Our hypotenuse is A what? AC. So which means sine of this angle theta is equals to BC over AC. How did it come about? Because it's opposite over hypotenuse. It's opposite over what? Hypotenuse. Are we together, members? Are we together?
We're together.
Yes. Number 2. The second one is what? Cosine, not so? Cosine, we said in short form is just called what? Cos. Cos of any angle theta is defined as the ratio of adjacent to hypotenuse. Adjacent to what? Hypotenuse. So it implies now cos theta is equals to, what is our adjacent, members? From our diagram here, what is our adjacent? The angle is theta. AB. So it's the same as AB over what? Over AC. Over AC. That is what we call cosine. That is what we call what? Cosine. In short form, we call it? Cos. Then the third one is what? The third one is tangent. The third one is what? Tangent. Which in short form, we call it what? We call it tan. Tan what? Tan theta is equals to, what is it going to be? Who can remind us? Is opposite over adjacent. So tan theta now, from our diagram, what is our opposite? Our opposite was BC over what?
AB.
Over AB. Is there any question on how we define these trigonometric ratios? Is there any question on them? Members, is there any question on them? Now, we use this one to find the size of the angle. We use this one to find the size of the what? The angle, or to help us to find Because trigonometry is all about the angle and the sides. The angle and the what? The length of the sides. So I'm going to give in summary. In what, members? In what?
In summary.
In summary, trigonometric ratios can be memorized. Can be memorized by using the word SOHCAHTOA. By using the word what?
SOHCAHTOA.
Put it in
What
quote.
are the meaning?
Put it in quote. Put it in quote. Sorry, put it in quote. By using the word SOHCAHTOA. Okay.
Teacher, the meaning.
Of course, I'm going to give. Who is that one?
Baru.
So in this case, S is standing for sine.
Sine.
Then C is standing for cosine. I think that. Then T is standing for
Tangent.
O is standing for opposite. H is standing for hypotenuse.
Okay.
Then A is standing for adjacent. Like that. Are we together, members? Are we together? Are we together
Yes.
now? Are we together now? Members, are we together?
Yes, teacher.
Yes. So that's how we memorize them. That's how we what? Memorize them. In case you have forgotten, just say what?
SOHCAHTOA.
Where S is standing for, so which means sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Then tangent is the opposite over adjacent. Have we noted it down? Have we noted it down?
No.
Yes.
Good. I'm opening. Let's move to the next page. Subheading relationship between trigonometric ratios. Relationship between trigonometric what? Ratios. Relationship between trigonometric what? Ratios. Relationship between trigonometric ratios. Members,
Yes, teacher.
are we together?
Yes, we are too.
Okay. Now, I want us to do something there. Let's say, consider a right angle triangle. Consider a right angle triangle. Consider a right angle what? Triangle below. But before we come to that right angle triangle, this right angle triangle, we are going to get it from somewhere here. Let's draw our Cartesian plane. Cartesian what? Cartesian what? Plane. If I talk of Cartesian plane, I'm meaning X and Y. X and Y what? Axes. I'm meaning X and Y what? Axes. Are you together, members? Are you together? These things that are all connected. They are all connected. Don't think that we learn and then we forget about the other. So if this is our X and Y axis, this is our Y axis, then this is our X what? Axis. Pick a compass, and then draw a circle to any radius. To any what? Draw a circle to any radius. Mine is there. Mine is there. Hey. What is wrong with my compass? It keep on moving away. Okay. Mine is not tight. I have to tighten this. I have to tighten this, but that's but yours must be better. Yours must be what?
Better.
Because my compass has problems now. So now from this point up to that, to the radius, to the circumference, sorry, to the circumference of the circle, then drop a perpendicular from there. Drop a what? A perpendicular from, like that. So you find that this line here is going to form an angle what? Let's call that angle what? Theta. Let's call that angle what? Theta. Then what is the distance from here up to here, remember? What is that distance called? What is it called? This is the radius, not so. That's the radius, right? Members, that's the what? The radius. So from here to here, because in the x direction, let's call x. Then this one, because it's vertical, let's call it what? Let's call it what? Y. Are we together, members? Are we together? Are we together? Members, have you drawn it?
Yes.
Yes.
Teacher.
Okay.
Yes.
Okay. Now, when you look at this circle of mine, how many portions do we have here? How many portions do we have? Because of this line I've created, how many portions do we have? There are 4 portions, not so. There are 4 what? Portions. The first one, because there's 1, 2, 3, 4. And this portion, we call them quadrants. We call them what? Members, how do we call them? We call them what? Quadrants.
Quadlets.
Quadrants. They are quadrants. Quadrants. Okay? Okay? And
Yes.
this one we call it the first quadrant. This is the second quadrant. This is the third. And then this is the what? The fourth.